Okay, so we'll start with page 58. People online, let me know if you change your mind. So, who asked about the page 58 one? Is that you, Lucas? Okay, perfect. So we are going to look at page 58, number 15. Let's see what it says. Okay, so this one, it was in the figure. Line BF is perpendicular to line AE. Angle B, the measure of angle BOC equals X, and the measure of angle GOH equals Y. Express the measure of the angle in terms of X, Y, or both. Okay, some of these can be a little tricky. So for number 15, angle COH. So I'm going to attempt to draw this diagram. It will not be the prettiest diagram because this thing is the bane of my existence. So let's see, just because I like to highlight and stuff when I explain a problem. So we got line AE, we got line BF, we got H here, pretend that looks like an H. That's point D. And then, it was almost good until we got to there. We'll pretend like that line is good. C and G. Okay. And then where it isn't in the middle here, we'll just put a really big dot there to cover up my mistake. All right, so you were given that line BF is perpendicular to line AE. So BF and AE. And angle BOC equals X degrees. And angle GOY or GOH equals Y degrees. GOH. So here's our diagram. You guys didn't miss much. You just missed me drawing a beautiful diagram. But we want to find, for number 15, angle COH. So angle COH is right here, COH. Okay, is this angle here? So there's a couple different ways probably to approach this, Lucas, depending on how you did the other problems. But if you take a look at HOD, isn't that a straight angle? Right. And if you take a look at angle HOG and COD, aren't those vertical angles? So what I would probably do is also too, if you see any angle in a picture like this, if you see anything that you know is going to be congruent, I would label that. Like here you have vertical angles. So angle Y here, or this angle, is angle Y as well, because those are congruent. And then you'd have the same situation down here with X, right? Because those are also vertical angles. That's just a good place to start. And then if you take a look, you should notice that you have your straight angle, which is always how many degrees? 180. And doesn't angle HOC include all 180 degrees except for whatever Y is? So what you would do for this one is you would say it's 180 minus Y. Does that kind of make sense? Okay. Were there any others on that one? Or are we okay with that? Okay. Is that it? Make sense? We're good? Okay. Page 64. So page 64, we're going to look at numbers 20, 21, and 22. Start with number 20. All right. So number 20, we are given that angle 3 is supplementary to angle 1, and angle 4 is supplementary to angle 2. We want to prove that angle 3 is congruent to angle 4. And we have this little diagram over here, and we have kind of like a parallelogram. We'll pretend like that looks nice. Okay, so we have angle 3 here, angle 4 here, and then we have 2 intersecting lines here with angle 1 and angle 2. That was obviously not an art major. So we want to prove that angle 3 is congruent to angle 4. And we are given that angle 3 is supplementary to angle 1, and angle 4 is supplementary to angle 2. So somehow we got to find a way to tie angle 3 to angle 4, right? So before we even start our 2 columns or any of that, let's kind of look through some of our logic here. If you take a look at your picture, does anyone notice an angle relationship that we've actually already talked about today? Brayden? Angle 1 and angle 2 are vertical angles, which means they're going to be what? They're going to be congruent. Good. So we're going to know that angle 1 and angle 2 are congruent. So and there's normally more than one good way to do a proof like this. But if angle 3 and angle 1 are supplementary, that means they're going to add up to be what? 180. Same with 4 and 2, right? So then we're going to be able to show that if 1 and 2 are congruent, right, they're going to have equal measures. We'll be able to kind of remove those. We'll end up writing an equation. We can remove those with subtraction and then show that 3 and 4 have equivalent measures. So I would always kind of look at it, see what you can piece together before you start. So I'm going to have my 2 columns here. So we have our statements and our reasons. And so my first statement is always just your what? Your given. Don't get that wrong. That's a freebie, right? Angle 3 is supplementary to angle 1, and angle 4 is supplementary to angle 2. That is given. All right. Step 2. Oh, and if somebody at home, it was actually Ben, our remote learner Ben, not our in-person Ben, asked if on this test, if I was going to give you any proofs that like you didn't have a table or anything for. Probably not for chapter 2, but count on it for chapter 3. Okay, so since this will kind of be our first test with proofs, there'll probably be a mixture of ones that are partially filled in, like your textbook does, and then ones that I'm going to give you a chart to give you some kind of guidance. But keep in mind, there's normally more than one way, so maybe you use one less line, maybe you use one more line, okay? But I will try to give you some kind of guidance. Chapter 3 kind of, all bets are off, and you'll probably at least get 1 or 2 totally like ones that you just have to go for it, okay? All right, so context clues, guys. If I give you supplementary angles, what can you say about them? Yep. And how would I show that, though? What would be the appropriate way to show that in a proof? Logan? Yeah, very good. We would turn it into an equation. So the measure of angle 3 plus the measure of angle 1 would equal 180. And I can do the same thing with 4 and 2. And it's up to you if you'd like to do that in one step or 2 separate steps. It uses the same reason, so you can combine it if you want, but you don't have to. It's not required. So then angle 4, or the measure of angle 4. So the measure of angle 4 plus the measure of angle 2 also equals 180. And what would I say for my reason there? What would be an appropriate reason? Ashley? Very good. Definition of supplementary angles. Remember, if I give you a vocab word, chances are you should then either use a definition or a theorem about it. Good. So step 3. What do you think I could do now? Nick? Very good. How do I know I can now set those equal to each other, though? Very good. And how do you know that substitution is appropriate, though? Okay, yeah, they're not congruent, they're equal, but also what do they equal? 180, right? They're both equivalent to the same thing. You could use transitive here. Transitive you can use either way. Substitution you can only use with equations, though. But yeah, very good. We're going to set these equal. So the measure of angle 3 plus the measure of angle 1 is going to equal the measure of angle 4 plus, and sorry, I have to go down here, the measure of angle 2. That is substitution. Okay. I'm not legible. I promise I have neat handwriting in real life, not on my tablet. What could I do now? This one's kind of a long one. We're not. We're like halfway done now. Maybe. Brayden, what do you think? Well, so we already set them equal to each other. You could say transitive property if you wanted to. That would be okay there. But we don't want to use it again yet. We need to introduce something new kind of into our proof. Peyton? Yeah, very good. I would go congruent first, then equal, just because your vertical angle theorem specifically states congruence. So good. Yeah, we had our vertical angles up here, which we're allowed to use. We just have to explain why we're using them, right? So for step 4 here, we're going to say that angle, was it 1 and 2? Yeah. Angle 1 is congruent to angle 2. And what do we say there? What's a good reason? Ashley? That is the vertical angle theorem. Now, I think I've said this before, but I'm going to say it again. My objective is not for you to have the names of a bunch of theorems memorized. That's not my goal, because the names of the theorems are very subjective. They could be completely different from one textbook to the other. My goal is that you know what they mean. So if you look at vertical angle theorem and you go, I know what that means, awesome. If you're in the middle of taking a test and you're like, I know vertical angles are congruent, but I can't think of the theorem. I can't find my vocab sheet. I can't think of the theorem. Give me an if-then statement. Those aren't your definitions and your theorems all if-then statements anyway? So that it would be completely appropriate to just say, if angles are vertical, then they're congruent. That would be fine. It means it's what it means. So it's just, you're actually being more descriptive. So that's totally fine. Good, so now I have that angles 1 and 2 are congruent, which is good, but is it in the notation I need it in? What's wrong with my notation? Ashley? They need to be equal. Yeah, we have equations, so we need them to be equal. Are we allowed to make that happen though? Yeah, absolutely. So for step 5, we're going to say now that the measure of angle 1 equals the measure of angle 2. What lets me do that? Ashley? Yep, the definition of congruent angles. If two angles are congruent, then they have equivalent measures. Very good. All right, so now this is good. I have that angle 1 and angle 2 are congruent, or not congruent, equivalent. So now what can be done with them? Sydney? You could. No, you could. You're not wrong. You could, like, you want to say you want to like substitute angle 1 in for angle 2, you 100% could do that. And then what were you going to plan on doing that afterwards? Absolutely. Guess what? You can do it that way, but you are doing one extra step that is 100% acceptable. You're just doing an extra step though. And that's okay. So like if you were taking the test, Sydney, and you wanted to do, okay, I'm going to plug in angle 2 for angle 1, and you would do substitution and then subtract it, I'm going to count that 100% correct. But I just want to tell you, because I always want you to make your life easier, not harder. Since they're already equivalent, you can go ahead and do that right away. So you don't have to do the substitution step if you don't want to. If that helps your thought process, then by all means do it. It's just not required. Does that make sense? Okay. So we're going to go ahead, since they're already equivalent, I can substitute them out, or not substitute them, subtract them out. So we can do that. Oh, so step 6. Is going to be that the measure of angle 3 equals the measure of angle 4. Good. And then Sydney told us that is the subtraction property. I like where we are so far. We're so close, right? What's the last thing we need to do? Nick? Yep, very good. Step 7, angle 3 is congruent to angle 4. That's where we need to get to. How come I can say that? Lucas? Definition of congruent angles. And a question I've noticed that I've gotten a lot is a few people have asked me, well, I've already used that. Can I use it again? Absolutely. You might use the same definition or theorem or property multiple times in a proof, and that's okay. Good.